and I'm starting a little bit early with this obsession. This particular obsession has barely begun. In fact, it's beginning. It's beginning right now. So hey, everybody, welcome. Nice to see everyone. Hey, Bobby, nice to see you. So yeah, I got a, I went out this afternoon and looked up, and the sky was almost completely clouded over. Right, you know, at first glance, right? It's like, wait a minute, wait a minute. It was supposed to be clear all day and all night. And I looked up and I'm like, wow, those are pretty thick clouds. So I was like, I don't know. So anyway, I got home and took a look at the satellite loop and noticed that there was one bunch, just one bunch of cloud. Right, this happens. I'm saying I don't think it's just for me, but it sure seems that way when there's a cloud right over my location and nowhere else in the entire Southwest. So, what am I supposed to say? Andy Cowley, hey, nice to see you. So, anyway, you can probably see in the background that there is the remainder of that cloud bank, right? You can sort of see it, but you can see that uh, all the way up here, and I guess I'm gonna take you all for a ride here. Here we go. Let's take a look at the situation here. Here's the here's the situation we have. So I would say that that is acceptable. There's no moon. I'm not going to see the moon at all if all goes well. um, and even if things don't go well, I'm still not going to see. I'm not going to see the moon. Anyway, so yeah, you can sort of see the cloud bank behind me there, right? But that's moving east, so that's gone. Right, it's totally gone. This is to my west. You can see a beautiful sunset. You can see above me. Above me here is just total blue sky. Right, it's total really nice. So I'm anxious to see. You see this. You see these clouds here. Sirius is right in the middle of these, and I doubt that you can see it, but it is. I don't think I can see it on my screen either. But anyway, so Sirius has popped, but Sirius is a pretty bright star, so it comes in early. Comes in early. So yeah, so that's the situation with the sky. Looks really good. As you can see, I am lightly. Well, I don't know if you can exactly see, but I am pretty lightly dressed. Let's grab the temperature gauge, and you will see that it's 65.3 degrees Fahrenheit, and the humidity is too low to measure, which means it's below 25%, right? Or 20% or something like that. So that's the situation with the sky. Now, the situation with the calibration is the following. I was eating dinner and completely lost track of the time. So I lost about 5 minutes right there. Right, I started about 5 minutes too late. Um, so I'm like, okay, that's all right. That's okay. I might have to take some longer exposures. whatever, right? So, um, so I drag everything out here, and I am so incredibly blessed, right? That um, I don't have to go anywhere to get the darkest, uh, some of the darkest sky in the world. Um, Now, it is definitely not the darkest sky, not even, not really even close, but it's very dark. So, and this location, in terms of the dark sky, is a dream that I had for uh, my my entire, um, probably first 30 years of life. Was It's like, you know what, I want a place that I can just walk outside my door, right? Walk outside my door, set up the scope, and that's it, right? Don't have to pack anything. Don't have to, um, worry necessarily about staying out too late because I've got to drive home. You know, all of that. No, I can. I mean, this is this is my place. So I mean, if I want to sleep out here with all the wildflowers, can you see those in the background here? We've got a bunch of wildflowers. I mean, it's the season, so it's really hard to kind of see because it's dark. But those are mainly poppies. Um, anyway, so if I want to come out here and sleep out in the poppies, okay, I'm allowed because this is my place. So yeah, I am thoroughly blessed to have acquired a location that I dreamed of, and wished upon every star for, and here it is. So it's it's amazing how wealthy I am in so many ways. Um, uh, and how poor I am in others. But that's all right. That's all right. Um, so anyway, so I got out here late, right? And then, um, it takes about 10 or 15 minutes for the camera, right? The camera here to cool down, right? And I'm actually telling it to work pretty hard, right? I want it to go to 10 degrees below 0 Celsius, right? And we can actually convert this. So it's like 18.1 degrees Celsius. I don't know why I did that. 18.1 Celsius, right? Oh, okay. So I'm telling it to drop to -10. So it's having to drop almost uh, 30. Is that right? 30 degrees Celsius. So that's a lot of work for this little guy to do. He can do it. He can do it. But it takes him, 10 or 15 minutes or so, right? So anyway, so I hook everything up, right? I've got it down to a science, um, by now, and so hook everything up, turn the machine on, turn on the camera, um, and then start up the software. And the first thing that you have to do, right, is connect to the camera. Now, there's this little ritual that this particular machine goes through, and I've noticed over the years that you really shouldn't or can't do anything until it goes through this little ritual um, that it has. It pops up a little thing um, which tells me that it's done. So I usually wait until that process happens, but I was very impatient, and so I started up the camera um, software before that little ritual had started. Um, so as a result, I was not able to connect to the camera. Multiple multiple attempts at doing that. Um, you know, stopped the software, restarted it, blah blah. Finally I'm like, okay, I'm gonna have to reboot. Right, I'm gonna have to reboot. Now the clock is ticking. Right, it's not as if time has stopped. It's not as if the Earth has stopped rotating. Right, so the sun is setting. Right, it's getting darker and darker and darker, as you can tell. Right, and so I'm like, okay, I now have to reboot the machine. That's going to take a few more minutes. I've already messed with this. Uh, so now I'm probably about 10 or 12 minutes late. And to get sunset flats, time is critical, right? You've got to be on time, or you're either not going to get your data, or your data is going to be pretty bad, right? And look, I'm having lots and lots of fun with this, right? But part of that fun is being like really picky and really um, um, uh, 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 wanting to uh, get the highest quality data that I can possibly uh, that I can possibly get, right? So I cannot and will not settle for anything better than an A, right? Now, you know, for many years, and I think a lot of people have this affliction, right? They want to always do A plus work, right? They want 99, 100%, right? That's that's the goal, right? And uh, you know, as a person who used to sort of think that way, in a lot of ways, it's very frustrating um, because it's a very rare occasion to get 100% on any effort. Um, so you might be able to do it on uh, like tests and stuff, but I'm talking about uh, doing things, right? Doing things so they're, perfect. No, don't worry about that, right? Um, I've I've adopted the good enough attitude, and that is I want to get an A, right? Which is 90%, right? 90% or higher, right? I don't have to get 100%, right? I don't have I don't have to get 95%. I can get 90%. In fact, you know what? I could get maybe 89, maybe, maybe on rare occasions, right? But so aim for an A. Try to get an A, or try to get a B, right? Aim high, right? But but you don't have to aim for that top 100% A plus. No, don't do that. Don't waste your time. It's no fun, right? Um, yeah, it's much more fun um, doing good enough. Hey there, Tom. I'm just blabbing away waiting for the sky to get dark here. Anyway, since I was about 12 minutes late or so, I looked at the sky over there and I'm like, man, I still have to let this camera cool. All right, so I've got another 10 minutes minimum. So that puts me at like 22 minutes late. And 22 minutes late is too long. It's too much. Um, so uh, so yeah, I had a couple of options in terms of doing this live stream. Oh, I'm gonna plug. Well, here, since I've got you unplugged, let's go look at the sunset one more time. Here, see what we're up against. See what's going on over here. So there you go. Looks pretty good. We've got those. There's there's this little patch here, right? That's kind of funny. And then there's this bigger one way to the east, So yeah, we've got some nice color, here. Look at that. That's great. Look how it's illuminating this white stuff here. That's kind of cool. All right, Sirius is definitely out. There's Betelgeuse. There's Rigel. There's the Belt. There's Procyon. Looking for Regulus. There's Regulus. Okay, so they're starting to pop. So yeah, so since I was 22 minutes late with having to do the calibration, I just decided to not do it, and instead just live stream here for a little while. I've got a plan. I've got to plug you in here. We're gonna lose power quickly. Whoop, that's why, because it's the wrong connection. There we go. Okay. Yep, we can do that. Okay, so here's the plan. My what is turning into my favorite little eclipsing binary star is doing its thing again in a couple hours. I think. Yeah, I think I'll have to look exactly, but I think the eclipse is supposed to start at 4, I believe, like 4:58 UTC, and go to a few minutes after 8 UTC. So for me, that's 10 p.m. to 1 a.m. So what I'm going to do is I'm going to end up at that star at the end. So that'll be my last target, right? Because I've got until 10 o'clock. Well, I want to start about 9:30. I want to be on target at 9:30. So I have to start looking for it probably about 9:15 local time, Mountain Standard Time, 9:15 p.m. So I'm going to have to start looking for it at 9:15. So that's in about 2 hours, right? So I've got 2 hours. Astronomical twilight ends in about 53 minutes. So I've got 53 minutes to, you can see those clouds behind me there. See them? They're just trucking on through. They're really, really bright though. So yeah, I've got an hour ish or so here to sort of kill, talking to you all and just sharing the experience of a beautiful, clear uh, Arizona night sky. This is the Arizona Outback, is what I like to call it, and yeah, that's exactly what it feels like. Um, so yeah, I've got about an hour until it's dark, right? And then I've got two, maybe three targets. Um, I again, just because I haven't really done this, I'm going to get some images of at least one galaxy, and that is going to be M65. I was looking at doing M51, the Whirlpool galaxy up over at Ursa Major, the Big Dipper. But I was looking at the star field around it, and there really aren't a lot of bright stars that I'm going to see in that field of view. And in order for me to do the the stacking that I have to do, I have to have stars in the field of view to tell me, how things have moved and how they've rotated. So I need at least two stars to lock onto. I just need two. Um, um, I can I've I've got code for either two stars or three stars. Three is as many as I need. Two is the minimum I need. So I had to do both. Um, so, but yeah, there weren't any really bright stars next to M51. So I'm like, well, so I went back to M65, and there will be a couple of bright stars in the field of view. Enough, I hope, to be able to lock on to. And then if there's enough time, um, I'll I'll move over to M66. Um, but there really, I mean, I'm gonna have about an hour or so. So the other target that I want to go after is um, uh, another kind of variable star. So XY Canis Minoris is what's called a variable star because its light curve varies, right? Sometimes it's bright, sometimes it's dark, sometimes it's in between. These particular variable stars are theorized with some pretty solid data to back that theory up, but theorized to be at least binary star systems, right? Where the two stars are going around one another. And uh, um, with some of those systems, um, just as luck would have it, their orbits are such that they sort of line up with our line of sight. So we actually see these stars passing in front of one another, right? And um, you know it varies, but usually one star, one component is brighter than the other one. So we call the brighter one the A component, and the fainter one the B component. And you can further sort of say that B is orbiting A, right? That's not exactly true. They're orbiting each other, and there's some kind of barycenter between them, right? Um, but so B is going around A, and so from our line of sight, sometimes B passes in front of A, and and it'll usually also pass behind A, right? So um, normally, what you see when you look at the star, now you can't see the individual stars. You can just see a single star because they're extremely close to one another, extremely close. Sometimes they're even touching, right? Um, so, uh, so yeah, um, So what you'll see, right, through most of the orbit is the light that's coming from both of these stars, right? As B is going around A, right? Most of the time you see the light from both stars. But when B is passing in front of A, then B is going to block A's light, or at least some of it, right? And when B is behind A, then A is going to block some or all of B's light, right? So what you see in these eclipsing binary stars oftentimes is sort of a double dip, right? So you'll have a primary dip, a, a very, very dark dip, and that's the fainter component passing in front of the brighter component, right? So, and that can, those usually last a few hours, right? Hours, um, yeah. Most of the periods of these objects are, either hours or days, um, maybe weeks, maybe, but they're very, very short period, right? So, and in the case of XC or XY Canis Minoris, um, it's a very, very short um, period. I think it's something like 14 hours, right? So these two stars, right? So, I can't imagine really what this would look like. But imagine, two stars, maybe sort of on the size of our sun, um, going around each other every 14 hours. So that's just mind blowing to me, right? But apparently it's happening. Um, and uh, and so yeah, that's what we see with those kinds of light curves is it's steady, 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 and then a drop, and then a rise, and then steady, 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 and another drop and another rise, shallower, right? So let's see. On this day, 1802, Heinrich Obers discovered asteroid Pallas. Very cool. So yeah, Pallas is actually one of the asteroids that I'm observing. Not tonight, but it's actually it it's not quite up yet. It's rising. It's right next to Arcturus. So if you know where Arcturus is in the sky, um, it rises. That's an airplane. Um, I think it rises maybe in about half an hour or an hour or so, something like that. But okay, yeah. And Pallas is number two. Pallas is number two. I think Ceres is number one, I think. That was the first asteroid discovered. And then Pallas. So anyway, so yeah, so that is the plan. That when I hit astronomical twilight, I'm going to go for M65. I'm going to sit on that for half an hour or, the entire time, right? Finding it and collecting data is going to be about half an hour. And then I'm going to switch. You know what? I can probably go about maybe almost 40 minutes with that. I want to get lots of images. So I'm going to have to stack them. Because with R Leo, I just need a few images. I don't need anything spectacular. Um, if I can spend 20 minutes finding and collecting data on R Leo, I will be a happy camper. So, okay. So what that means is that puts me um, local time at a little bit after 9 p.m. So that puts me in exactly the right position to move over to XY Canis Minoris and get that guy. So I'm just sort of wondering, yeah, it should be up during those 3 hours. I don't think it's gonna. No, it's not gonna get incredibly low. Let's see. Let's see where it is now. So Procyon is still actually this side of, or the east side of the meridian by a little bit, maybe half an hour or so. So half an hour, and then another 3 hours, or no, it's so it's 2:18 UTC, and I'm wanting to go um, until 8 UTC. So that's another 6 hours. Okay. Well, shoot, I might not be able to get that whole thing. Dang. Yeah, I didn't think of that. I didn't think of the fact that it was, because it's crossing the meridian now. So in 6 hours, it's going to be setting, right? But 6 hours from now is when the eclipse is supposed to be ending. So, oh man, oh, well, that throws a wrench in things. Um, I'll go ahead and collect data as long as I can with that. That's about as good as I can do. Um, yeah, in 2.5 hours, that thing's going to be way over there. So, yeah, I'm only going to have a couple hours on it. Dang. So I'm not going to see the whole thing. Shoot. Yeah, I forgot about that. Okay, well, I'll see it all. I should be able to see its midpoint. Um, I'll have to look and see exactly what time that's taking place, but I want to say I want to say that that's going to be happening. It's a pretty symmetric um, light curve, so it's about a 3-hour event. So the midpoint should be about an hour and a half after the start, and I know that the start is at is at almost 5 UTC. So midpoint is going to be 6:30 UTC, which for me here is 11:30 p.m. 11:30 p.m. is 4 hours from now. Wow, so that's going to be way down there. Okay. Yeah, I should be able to see it though. I should be able to see the midpoint. So, okay. Well, that's how it goes. Yep, you gotta think about those things, and I like sharing that kind of thought process with you all. So, um, as I said, these I'm gonna go a red face on you. The these are the kinds of thoughts that I have in my head anyway. So I'm just saying them out loud. Um, that would be, you know, what I just went through there in terms of a thought process, trying to figure out, you know, um, I, what I'm fundamentally trying to determine if I should even do it, right? But yeah, if I can get the start and if I can get the midpoint, then it's worth doing. So yeah, if I can only get a piece of it, it's not quite as valuable. Still valuable, but not much. Okay, well, it's definitely dark enough to do the star alignment and the calibration or the focus, and the temperature of the camera is now a nice stable um, negative 10 degrees Celsius, and it's having to work a little bit hard to keep that temperature, which means it's probably not going to be incredibly stable, but I think we're good. It is having to work a little bit hard, but not too bad. Not too bad. Okay, so the thing to do is a star alignment. So I'm going to get you set up over here too, so you can watch the antics, which I know you like to do. I'm going to knock this down to 1/10 of a second exposures. These are bright objects. And you know what? I didn't set anything up beforehand, so let me get all this going. Um, our first target is going to be probably. You know what? I'm going to do our Leo first. I'm going to do our Leo first, get it over with, right? And then I'll know exactly how much time I have to do M65, because I want to maximize my time on M65, so I can keep an eye on the clock, and I can just go collect M65 data until 9:15 p.m. exactly, and then I can move over to XY. Yeah, I think that's the plan. Okay, so my first object is going to be our Leo, not Loey, Leo. And I need to make a new folder. It's going to be. So, like that. Okay. So, sorry, you're just seeing absolute blackness. We ready to go? Yeah, we're ready to go. We're not saving. I'm going to be doing the green filter. Green filter. That's the closest to the Johnson V filter. So that's why I've chosen to use that. All right, I'm going to try to get you set up here so we can all play along. So let's see here. Scoot you over a little bit more. Okay, that's not going to be too bad. Oh, it's a little big. Come on. Come on. Gotta shrink down, dude. There we go. Sorry. Okay. So, step number one, take the cover. Take the cover off the telescope. All right, that's accomplished. Let's put this over here. Let's see what our temperature is. 18.3 degrees Celsius, and still too low to measure. That's an indoor temperature, so you can ignore that. Yeah, so too low to measure out here still. I like it. I like it. Don't want to step on things. Okay, so we're going to go for Procyon first. I need to set my time. In fact, I got to turn the telescope on. How about that? Interesting concept. Coming over here, grabbing the paddle, and it's going to be 7:27. 19:27:000 in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, now. Okay, standard time, mountain, 03:28. It's still the 28th here. 19, enter. Okay, we're going to do the usual suspects. We're going to do Procyon and Rigel. So here goes Procyon. I turn on my little finder scope finder. And here we go. It's gonna start of a. It's gonna be a pretty productive night, I think. Pretty fun. If if you call collecting data fun. I don't know if I do or not. I think I'm not incredibly close. Should be there. Cool. That's pretty close to the middle. I think I'm gonna go with that once I get it scooched over. There we go. Yeah, that's vertically, I think that's acceptable. Just gotta scooch them over there. Come on, scooch. This next one, let's see. Oh yeah, bam. Okay, got him. All right, now we'll go to Rigel. Going down to Rigel. Be pretty close. Yep. Scooching up that way. Don't lose him. Up. Up, there he is. We've got him. Up. I'll go down a little bit. Come on. A little bit more. That should be about right. Let's see if I got it. Oh, it's going to be really close. Watch this. Oh, yeah, look at that. It's getting closer. Here we go. One more. Oh, yeah. Okay, alignment success, it says. All right, cool. Let's focus. Oh, shoot. Okay, off my knees. Done my bowing to the telescope for the evening. Have to get down on your knees to these things. So as soon as I get this in the middle, I'll put the batten off mask on there, and we'll make sure we're focused. It's drifting up. At an alarming rate. Oh, bam. Dang it. I want to scooch him up, and then I want to scooch him. Well, I don't really care if I have to scooch him down, but I want him scooched up and not drifting. I'm going to throw the batten off on there. Yeah, that's a pretty good spot. So how does our focus look today, boys and girls? Looks pretty bad. So I'm going to go this way. That stupid thing. Drifting. I think that's better. Yeah, let me go that way a little bit more. Just a touch. How does that look? That's a little too far. I don't remember which way I went. I think maybe that way. I think that looks pretty good. No? No? I think that's okay. Let me... Shoot. See, I mean... This is part of that thing I was talking about earlier with the 100%. Okay, I'm gonna go with that. That looks pretty darn good. Getting a little bit of wind here. Trying to get the Batinoff mask off. Alright, I'm gonna move this guy. It's not blasting my poor thing. Hey there, Carolina Sky Astronomy. Viewing the Orion Nebula. Cool. Well, I've got some great dark sky here. Clear. No moon. Yeah, it's starting to get nice and dark now. Stars are starting to pop out for sure. So, let's see, what should we do here? We've got about half an hour, a little less than half an hour, maybe about 25 minutes or so before it's dark enough. Seems about right. Well, let me think if there's anything particularly interesting. Not really. I mean, there's all kinds of interesting things. But what do I want to struggle for? I think I'm into struggling. Yeah, I don't know. Looked at M41 the other day. Looked at M46 quite a bit. Looked at M79 the other day. That was kind of cool. Got some clouds to my south, the southwest or southeast. But they're going to be moving east, so no problem. No problem at all. Well, yeah, and the wind has decided to kick up a little bit, so that's not very good. Wind jiggles the telescope just enough to mess up the images completely. You might even be able to tell that with the image that you're seeing on the screen. These two stars here. You can see sometimes they're little smears. I mean, right now they're all right because we got good sky, or we don't have a lot of wind. I'm gonna plug in my thumb drive that has my charts on it. Plug that guy in. And that should pop up that. And we'll do that. And we'll get right into here. 28. So it's going to be our Leo first. Yeah. So There this little guy is. That guy right there. And so you can see that there's another pretty bright star up here, but it's these our Leo itself and this star are too far away from one another to fit into one field of view. So what I have to do is I have to take a bunch of images with this, and I can use these two stars as my alignment stars, and then I move to this star and take a similar number of images of that star. So if I do 100 of these, I'm going to have to do 100 of these. So I don't even really think I need to do 100. I'm going to do like 50 of each, and I think that'll be adequate. Yeah, I think so. Methinks so. Well, let's see. We've got a little bit of time. We could. It's a lot of moving around, but it doesn't really matter. I was thinking about looking at Alcor and Mizar, the binary star in the handle of the Big Dipper, just for fun, just to see if we could separate the components of. Is it Alcor? Well, I think both of those stars are at least binary stars, but I think the one that we can see is, I think that's Alcor, is the bright one, and that's a visual binary. I think you can actually see that with the scope. You can swing over there. We could swing over there. Let's do it. Move this away. It's pretty low up in my northeast, but I can definitely do it here, I think. Pretty close. I'm gonna get on my hands and knees, or on my knees again at least. Now, what's going to be challenging is that's not so hard, I guess. Let's see if it's there. Yeah, there it is. So you can actually tell it's a double. You can see how it's. Try to scoot that down a little bit. And if I, what I can do is change the binning. Change the binning to like 2x2. We'll actually be able to see something. Scoot you out a little bit. There we go. Here, you can definitely see that it's extended. So this software does some kind of an auto stretch, and so yeah, it looks like a snowman. But yeah, I think that separation is like 13 arc seconds. So on this scale, that would be about maybe 6 pixels, 6 or 7, something like that. But maybe it's like 30 arc seconds. I don't remember. Exactly. So I don't think, might be able to do a shorter exposure here. Let's see. 0.01. Let's do like, I don't know if it can go that fast. No. I don't think it's going quite that fast. Let's go 0.05. Yeah, no, I think that's all we're gonna get with that. So okay, well that's fun. Alcor and Mizar haven't seen Alcor and Mizar in a little while, so it's nice to see them. We can actually go one by one binning if you want. Let's go totally crazy here. Takes about 14 seconds to download a full frame image. I'll zoom you out a little bit again. Yeah, there we go. That's even better, right? So yeah, I think that's Alcor. Mizar is going to be, I don't know. Mizar's in the area, but yeah, now you can definitely tell that there are two stars there for sure. I don't know where Mizar is relative to this. I'm trying to remember. We can scooch around a little bit and see if we can pick it up. Not too far apart, but I don't remember exactly which way to go to find Mizar. Well, we can poke around a little bit and see. Let's go back to 3x3 binning because that is going to just take too long to download. Okay, so we'll just go back to Schmall, and we'll poke around a little bit, see if we can find him. I don't know. I should be able to get these both in the same field of view, I think. So I'm going to move him up. That's not moving up, that's moving down. Okay, let's move down. See if we can pick up Mizar here. As I said, I don't remember where he is. It's getting pretty far down. Okay, well, he's not there. So let's go over this way. Oh, come on. We gotta go to the left. There you go. There's a nice cosmic ray on the left there. Okay, we're gonna scooch him over. Keep going. You're doing very well. Still picking up a little bit of a breeze here. That's a no-go for observing. Can't have any breeze. So yeah, not picking up Mizar anywhere. It's just out of I mean, it could literally be just on the other edge of that field, and I would never see it, you know. So we'll cover it all here though, just to make sure. Oh, is there something coming up? I don't know. Oh, that's a little star. Okay. I was hoping. So yeah, not seeing Mizar anywhere. It's got to be. Well, it's got to be. Yeah, I don't know. Not seeing it. Hello there, kitty. What you doing, Bubby? Huh? Alright, well, that was pretty cool. So there's Alcor again. Cool. Alright, well, you know, it might take me a little bit of time to find our Leo, so I'm going to go for it. And you can watch the shenanigans as I attempt to find this target. So here we go. So first thing I'm going to do is I'm going to change the, well, I'm going to move this thing actually. It is cool to split binary stars. I totally agree. Okay, so we're gonna raise this to 1 second exposures, and then we'll probably go a little bit longer once we get on it. But here we go. So this is 1 second exposures, and I'm going to dial in the coordinates for our Leo. There we go. Go to RN deck. Here we go. 09 47 33.5 and positive 11 25 44. Let the fun begin. Now I still got wind, so I'm still a no-go in terms of actually collecting data. I'm going to dim this smartphone, which means I need to cut you off just for a couple of seconds, but I will be right back. Okay, hold on just a second. Okay, I should be back. Yeah, I just had to dim the smartphone a little bit because it's really bright. It was really, really bright. Okay, our Leo here, right? The chart. And I've got our Leo there. And yeah, you know what? Yeah, good. So, okay, well, here we go. We're gonna start looking. So I've got the green filter in there. And I guess I am gonna zoom you in a little bit so you can see a little bit better there. So, okay, well, there's two stars relatively close to one another, and I wonder if I move it this way. So it's 7:51 p.m. Is there a brighter star right next to them? Hey there, Tim. Nice to see you in the chat. Glad you could stop by. Get some rest, dude. Definitely. And take care. Okay. So I've got a pattern here, and I'm thinking that you see 1, 2. Why is that in that weird mode? You see this one, and this one. So these two are about the same, and this one's brighter, right? I think that's these two, and this one, right? I think that's right. So if that's true, then see how these things sort of point to this guy? So I just need to go that away, right? So I'm going to scoot him down. I'm going to scoot this thing down. If my theory is correct, which I think it is, So I'm going to scooch these guys down a little bit. And then I'm going to scooch them so they move to the right. So here we go. And that bright star should pop in from the left. And it's a little bit lower than what I want it to be, but we should still see it. Okay, here we go. So we got a whole field of view that's going to be empty, but there's that bright star coming in on the right, or on the left. Yeah. And our Leo should be to the upper left, if I've got my bearings right. So yeah, this is cool, dudes and dudettes. This took me, well, I'm not quite there yet, but that is my reference star that I'm going to use. But I want to make sure that I've got our Leo in here too. Somewhere should be popping in, I think. Yeah, there's, I think, one of the reference stars up there. So if I go this away and then move the stars down, so here's those guys. Yes, sir. Good old-fashioned star hopping using star charts. Just the way I like it. All right, there we go. Okay, so there's our Leo. This guy right there. So I'm going to get him about in the middle. So, cool. That took me 4 minutes. Okay, that's how it's supposed to work. That's how it's supposed to work. So I'll get right down here. Make sure he's stopped. Scooch him up a little bit. Maybe scooch him over to the right a little bit. That looks pretty good. Okay, well, I've got wind. I've got a little bit of wind. It's just gusty though, so you know it's not too terrible. It's not too terrible. So our Leo is about as bright as it's gonna get. It's just like in the past 30 to 40 days, it reached its peak, and now it's starting to dim again. And it dims pretty significantly. I forget now, but it's going to get pretty darn faint over the next few months. So I'm just collecting data on this every chance I get. And there we go. Hey there, Desiree. Nice to see you in the chat. Thank you for the support. We're out here, and actually I just acquired my first target, which is the variable star R Leo. So I'm basically just sort of waiting for astronomical twilight to end, which ends in about 5 minutes. So, but yeah, there's my first target. Had no trouble finding it. So that bodes well for the rest of the night. So I definitely have to keep these two stars in the field of view. If I lose either one of those, then I'm going to lose that whole image, right? Because it's not going to, my software isn't going to be able to find those two stars, because one of them, like now, isn't going to be in there. So you know what I should do? Let's mess with exposure time. So I'm gonna. Okay, that can go away. I'm gonna go to 2x2 binning, which is what I'm gonna be doing tonight. And let's do a 3-second exposure and see See what kind of signals we get there. What kind of drift. If I get nice round stars, I'll be happy. Oh, wow, those are pretty nice round stars. Yeah, yeah, it's the season. So, wow, that's pretty good. I gotta say. There's a little bit of drift, you know. I'm gonna go down to 2 seconds. Yeah, that's pretty good. Just got to keep all three of those stars in the field of view. If I can do that, then I will get good data on this. Cool. All right, well, I'm ready to rock and roll on this, and I've got about less than 3 minutes to astronomical twilight. So I'm gonna give the universe those 3 minutes, and then it's gonna be non-stop until, well, probably another 4 hours, four, maybe five. We'll see. Pretty good tracking. Pretty good. So this is R Leo, R Leonis. It's called a Mira type variable star, um, which means it's a single star that is varying in brightness over time, and it's a pretty significant variation in brightness. I don't remember off the top of my head, but I I want to say right now this star is at about a magnitude 6.5. Um, and I think it peaked at about 5.5. And I think its faintest is somewhere around like 10, something like that. But yeah, this is looking really good. The tracking is looking really great. I'm tempted. I'm tempted to do 3 seconds exposures, but yeah, I think 2 seconds will be fine. I'm going to get 50 images of this, and then 50 images of my reference star, and then I'll be done with that. So, okay, here we go. Well, I've got another minute or so. Yeah, yeah, I think 2 seconds looks good too. I don't know if you can see down here, but my max value is about 22,000, 20,000. So I'm pretty happy with that. That's a good signal to noise. If I increase that by another second, I'd increase it by a third, and mm, that could be all right. But yeah, I'm seeing a little bit of tracking drift, and these stars look pretty nice and round. So I'm gonna go with that. Okay. So I just gotta turn autosave on, and make sure that we're starting at 0. Got the right folder. All right, here we go. So we're gonna take 50 of these. 50. Here we go. And I'm going to keep track of this. Oh. There they are. Okay. Oh, we're drifting a little high there. Scooch him down. Probably maybe smudge it a little bit. That image, that data right there might not be any good. That definitely won't be any good. Losing data already. There we go. Might scooch him down a little bit more. We'll see which way he drifts. Looks like he's drifting up a little bit still. Still getting a little breezes. Scooched him down again. Probably smudge this one. Smear it. Yeah. I might scooch that down a little bit more. That's a pretty good spot. Yeah, that didn't drift at all. Let's see what this one does. I drifted a little bit. So not too bad. Not too bad. Anyway, yeah, so this is just a single star that is brightening and dimming in sort of a periodic way. And if you look at the light curve, brightness versus time, it sort of looks like a sinusoidal curve, right? Up, down, up, down, up, down, like that. So, and it's a pretty long period variable too. I want to say something like 300 days. So, seeing any change over the course of even one night is unlikely, unless you're looking for very very subtle changes. Um, but what I'm doing here is just anytime I'm out and it's up, I'm going to collect some photons to make that brightness measurement, and then I'll fill in that sinusoidal pattern with my own data. And that in and of itself probably isn't too interesting or useful. So, I'll have to think about what else to do with that at some point. But for right now, this whole thing is just sort of an exercise to see what the capabilities are. Um, you know, uh, for a lot of these things, it's the first time that I have ever done this kind of stuff. With my own system, all of that. I mean, I've done this kind of stuff at the big scopes, right? At the pro scopes. Um, uh, but yeah, it is definitely not the same. Oh, it's starting to drift down a little bit, so I think I'm gonna scooch him up. Let's see how scooched he is there. Should show up on this one. That's pretty good. Still getting a little bit of a breeze. Um, let's see. The thing about collecting photons is we never have enough time to get the data we want to get. Yeah, yeah. Cool. Yeah. 5 seconds. So, oh, why am I not? I think I pushed the wrong button, and now I'm in trouble. Okay. Well, I think I think this is correct. I'm gonna just because I'm gonna switch this back to. I want to be consistent, right? I'm gonna switch that back to Fahrenheit. I'm gonna go over here and mess up the next exposure so I can scooch that thing up a little bit. Anyway, I wanted to show you the conditions out here. Oh, okay, that didn't mess it up. So there we go. Oh, come on. 61.3 degrees Fahrenheit and humidity too low to measure. I like it. So just a couple more images here and we'll be done. And we'll scooch on over to the reference. And then, okay, so now we need to move over to the reference. So I'm going to temporarily stop taking images. Oh, didn't mean to do that. Oh, let's go back to 3x3. That's the fastest. Don't have to move very much. I just need to know where to go. So we need to go that away and that away. We need to go to the left and we need to go up. There he is. So I can, because it's a single star, and it's actually, the target that I'm interested in measuring, I just have to have this one star in the field of view, and I will be happy, because I can stack a single star, right? Field rotation doesn't matter. So I'll get them about in the middle there, and we'll take 50 of these. And I've got about an hour and 5 minutes before I need to start getting on to XY Canis Minoris. So that's just about perfect, I think. Okay. So that's a nice bright star. I'm getting max counts of like 40,000. So that's a nice bright star. So we're going to call this, yeah, we'll just call it the same thing, or Leo. I'll know what to do with it. So we'll take 50 of those. 2x2 binning. Decent download time. Single star. That's about as boring as it gets. Actually, there's another one right there. So it's not totally boring. So after this, it's M65. And I don't know, should I I can probably keep this live stream going for a little while longer, get on to 65 and then call it. I scooched that down a little bit, that's why it looks so funky. Oh, he's on the move. Okay, that's all right, as long as he doesn't go anymore. Yeah, he's starting to drift up a little bit again. Okay, that'll be good. So, yeah, I can. I guess we have options, right? We could end the live stream now, because it is 3:12 UTC. I understand that it's getting a little bit late, and definitely respect everybody's time. Greatly appreciate everybody coming in. That's always awesome. Awesome to have a nice little crowd here. So very cool. This is I don't know much about this particular star. Is this one? Yeah, I don't. I don't think it was this one, but maybe it was. is this star a variable star too? I don't remember. Yeah, I don't think so. I think that was something else. Oh no, the reference. I think the reference star um, that I use with XY Canis Minoris. I think that's also an eclipsing binary star. So it's almost always the same magnitude. Um, so yeah, I, I I just use that as a reference. I think that'll be all right. Let's make sure that we've got data here. It's always nice to know that the data exists. Yes. Yes. Actually has size. Good. Good, good, good. So just as long as I keep that star in the field of view, we're going to be good. And we're almost done with this one anyway. Just got about 20 more images to go. Drifting down a little bit, so I'll scooch him up on this next download. So let's see how much he scooched up. Oh, sorry. There we go. That'll probably be all right. Scooching down still a little bit, so I'm gonna just push that one more time and call it good right there. Yeah, that'll be all right. That will be fine. So after this, I'll probably take like 20 darks, 2-second darks. 20 is just sort of an arbitrary choice. The more, the better. So, I could sit here all night and take darks. But then, of course, I wouldn't have any data. um, so, you have to make a compromise. And 20 to 30 darks is at least what I've observed to be, good enough, right? I get an A. There probably is some kind of optimal thing, but forget it. I'm not going to get into 100%. If I can get 90%, that's good enough. And that is. So still drifting down a little bit, but we've only got a couple more images to go, so I'll just let him drift around. The software that I use will use what's called a peak finding algorithm. It'll just find the brightest pixels in this image, and then it'll compute a centroid on that to get the exact location of the brightest object in this field, which is going to be that star. And then based on that location, which could be fractional pixels, right? Um, um, it'll add up the values of all the pixels in a certain radius from that center, and that is the brightness. So let's do 20 darks. 20 darks. Switch that to a dark, and that'll be nice and quick. So let's see what our dark values are. I was getting around 30,000 peak. Now I'm getting around, that's 959, 944. So yeah, we got good signal there. Nice bright star. Yeah, that's got to be like a six magnitude star. So almost bright enough to see. If I knew where to look, I'd look for it. Because yeah, well, magnitude 6.5 R Leo, yeah, I'm not going to really be able to see that. Magnitude 6 is pretty tough out here. That's about the limit of my vision. So yeah, here's the darks. This is this data that I just took. It sits on top of this pedestal, right? Which is uh, one form of noise. It's noise that's actually generated um, uh, by the camera itself, and it can accumulate, right? So that's why I've got to do a 2-second dark, which matches the 2-second exposures I took. So and then in the reduction process, I average all these dark frames. So I take all 20 of them, add them up, and then divide each pixel value by 20, and that produces an average sort of master dark. And then I take each of the raw images and I subtract the master dark from them, and that removes that pedestal. So there's no more camera noise. Then of course I have to flat field it, which is another process all by itself. But I think we are pretty much done here. Last dark. Cool. All right, we're done. We're done with our Leo. Yay! So let's move to M65, and then I'll let you all go. How about that? So I'm gonna switch that there, and I am gonna go to 1-second exposures, and hopefully I did autosave. Yeah. Since I'm here, I might as well get this all set up for M65, being hopeful. So we'll go back to 3x3 binning. Autosave is off. Okay, we can rock and roll here. All right, grab my notebook again, which has the coordinates for M65. I could also just punch in from the paddle here. So why don't I do that? 065. And I'm going to pull up my charts. Oh, let me just do it this way. Whoop. M65. Oh, I pulled it up twice. Oh, I didn't. There we go. So, of course, this isn't showing the galaxy, but the galaxy itself is right here, and M66 is over here. So, yeah, that's sort of the pattern I'm looking at there. Uh-oh. Did I do a bad thing? Oh, man, I did do a bad thing. I did a bad thing. Picture's on. Yeah, somehow, for some reason, I killed this thing. Don't know how, don't know why, but we're rocking and rolling again, so we're all right. Okay, so we're at 8:22, and oops, sorry. So let's see how well I do with this. So right now I see nothing, but it's a pretty sparse area of the sky too. Right, it's pretty sparse pretty sparse area. So we're gonna definitely have to move around to find anything. So let's start moving around. I'm just gonna arbitrarily choose. I'm gonna do a little educated. Um, with our Leo, I landed right about there, right? So I don't know which way that is. I think I was having to move stars to the right. Is that right? Yeah. So I'm going to do the same thing, I think, and see if anything pops up here. This is going to be a little bit more challenging because there aren't a lot of stars. It's sort of the opposite problem when there's too many stars. Now I see some really faint things, but and of course I can also look for the galaxy itself, right? I'm thinking I'll be able to see a fuzz. Yeah, there it is. Dang. Yeah, that's it, all right. We'll confirm with the star patterns, but that's a fuzz. So let's see. Yeah, that's hard to tell. Um, because of course I want to get the right one. So I think what I'm going to do is I'm going to move him over just a little bit more to the right, and then I'm going to move him up and see what's there. Because I'm not sure what star that is. Is that this, or is it this, or is this M66 and I'm looking at like this? Right. So I'm going to scooch this guy up. Okay, that is for sure. That is M66, right? Because I think these two stars are these two stars. If I go, um, if I keep moving these guys up, I should see these two um, coming in from the bottom. So let's just confirm that, but I'm pretty sure that's what we're going to see. Yeah. Okay, so there's those two. Okay, so we're there, right? We're right here. So we just need to keep going that away, right? A little ways. No problem. Should see another fuzz. So that was M66. A little surprise. Now, dang, the one thing that I want to get into the habit of doing is actually saving uh, uh, these finding images. Okay, there it is. I can see it. It's over on the right or on the left. We'll scooch him over. You see him right here? Pretty. So there's that faint star. I think that's this guy. Scooch him up a little bit. Definitely want to do longer than 1 second exposure. I'd like to get away with 3. But I want to get this bright star in there. And I think there he is. Okay. That's good enough. So we'll scooch him up. And then we'll go to the 2x2 binning. Okay, so there we go. That took 5 minutes. Exactly. Exactly what should be happening here, folks. Okay, so there's M65. Um, so let's see if I can do a 3-second exposure. A little bit of a drift. It's a nice stellar nucleus there, isn't it? That is sweet. I got to keep those two stars in the field of view because those are my locking stars. Those are my tracking stars. That's beautiful. That's great. Okay. So as of right this moment, there's another buggy. They're coming out. So as of right now, I've got 45 minutes. Um, I've got to do however many images I'm going to do of this, and then I've got to do my dark images, right? And then I'll be ready to go. But I've got 45 minutes on the sky. So that is pretty awesome. Um, yeah, I think what I'm going to do is I'm going to set it up for 100 images, 100 3-second images, and we will go from there. And I think I'll get this started, and then I'm going to end the live stream because I've been going for a little while. Let's see. Okay, so let's abort and M65. We're ready to rock and roll. I'm going to scooch him down and over even before I get started. All right, let's do it. Oh, I want 100 here. Beauty. It's a good starting place. All right, well, everybody, I think I'm going to get out of here for now. So thanks so much for coming in, joining the fun here on this ever continuing obsession of mine. Um, Never seems to end. Just seems to get funner and funner as we go along. So, yeah, this will be at least one of the first galaxies that I really looked hard at with this system. So, pretty cool, pretty cool. All right, everybody, I'm gonna get out of here. Just gonna make sure that this is coming up okay. Looks like it is. Excellent. Okay, everybody, take care. I will see you on the spin. Thanks for coming in. Spread the word.